Very good morning to all of you. Today I want to start session 6 of module 4. Title of module is Bearing Capacity of Shallow Foundation, and course outcome of this module 4 is ability to determine bearing capacity of soil and achieve proficiency in proportioning shallow, isolated and combined footings for uniform bearing pressure. So this is the course outcome of this module 4. Title of subject is Applied Geotechnical Engineering. Subject code is 18CV62 in 6th semester of Civil Engineering departments. So last class we have seen 5 problems, how they have asked and how solve those type of problems. So in this session also I want to solve this 6th problems, how that problem is asked. Okay, let us see. Determine the SBC for a footing 2 meter by 2 meter in size, founded at 1.5 meter below ground level on silty sand with following properties: C equal to 8 kilonewton per meter square, phi equal to 26 degree, gamma equal to 18.5 kilonewton per meter cube. Use factor of safety 2.5 for first case, water table and grade depth. Second case, water table at foundation level. Take NC equal to 14.8, NQ equal to 5.6, N gamma equal to 3.2. Solution. What are the given data given in these problems? Size of footing is 2 meter into 2 meter. Depth of footing is given 1.5 meter. Unit weight of soil is given gamma equal to 18.5 kilonewton per cubic meter. C is given 8 kilonewton per meter square. Phi is given 26 degree. Bearing capacity factor NC equal to 14.8, NQ equal to 5.6 and N gamma equal to 3.2, and factor of safety is given 2.5. To find first case, QS equal to how much, that is safe bearing capacity equal to how much if water table at great depth. And second case, SBC equal to how much if water table at footing levels. So here 2 cases are there to solve SBC. So this problem is with water tables. Procedure. First case, if water table at great depth, then how to solve SBC? Draw the diagram based on this condition. So this is the ground level, this is the depth of the footing 1.5 meter and width of the footing is 2 meter. Soil density is given gamma saturated 17 kilonewton per cubic meter, and water table at great depth means below the foundations. So this is the water tables located from here to here. DW, it's great depth, and this distance we are considering as a ZW2 is equal to B is equal to 2 meters. So this depth, and this above the base of the footing below ground level, this distance we are considering as a ZW1. So it's become 1.5 meters. Okay. Step 1. Ultimate bearing capacity for square footing is given by the following equations: QE equal to CNC plus gamma DF NQ RW1 plus 0.4 times B gamma N gamma into RW2. So this is the general shear failure because silty sandy soils. This equation is based on general shear failures. Okay. Calculate RW1, water reduction factor. is given by the equation 0.5 times 1 plus ZW1 by D. So here ZW1 is 1.5, D is depth of footing 1.5. So then while solving this equation, we are getting RW1 is 1. Similarly, you calculate RW2 is given by the concept 0.5 times 1 plus ZW2 by B. Now substitute the value in this equation. Here ZW2 is 2, B is 2 meter. So answer is 1. So water reduction factor is calculated by using these two equations. Now substitute the value in the above equations. Okay. So here in this equation, C is 8, NC is 14.8 plus gamma is 18.5, depth of the footing is 1.5, NQ is 5.6, RW1 is 1 plus 0.4 times gamma is 18.5, B is 2 meter, N gamma is 3.2, RW2 is 1. So we are getting 321, that is 321.16 kilonewton per meter square. This is the ultimate bearing capacity. The next step, net ultimate bearing capacity is given by the equations QNU equal to QU minus gamma into DF. Now substitute the value in this equation. Here QU is 321.16 minus gamma is 18.5, DF is 1.5 meters. So answer is 293.41 kilonewton per meter square. Next you calculate net safe bearing capacity. QNS is given by the equation QNU by factor of safety. So substitute the value here. QNU is 293.41 divided by factor of safety is 2.5. So answer is 117.36 kilonewton per meter square. This is a net safe bearing capacity. Now we calculate safe bearing capacity is given by the equations net safe bearing capacity plus overburden pressure, that is gamma into DF. So now here net safe bearing capacity is 117.36 plus gamma is 18.5 into DF with depth of the footing is 1.5. So answer is 145.11 kilonewton per meter square. So unit is also most important. So don't forget while writing the unit. So this is the first case. Solve second case. If water table at foundation level, so from the diagram, water table at the foundation levels, this is remaining dimension are same. So then how to solve? So here this is ZW1 is 1.5 meter, ZW2 is 0. Okay. So therefore ultimate bearing capacity for square footing is given by the following equations, that is QE equal to CNC plus gamma DF NQ into RW1 plus 0.4 times B gamma N gamma into RW2. So this is the main equations for ultimate bearing capacity calculations, where you calculate water reduction factor. RW1 equal to 0.5 times 1 plus ZW1 by D. So here ZW1 is 1.5, D is 1.5. So answer is 1. Now we calculate RW2. RW2 equal to 0.5 times 1 plus ZW2 by B. So in this equation, here ZW2 is 0, B is 2, so answer is 0.5. So after calculating RW1 and RW2, you substitute the value in the above equations, that ultimate bearing capacity equation. C is 8, NC is 14.8 plus gamma is 18.5, D is 1.5, NQ is 5.6, RW1 is 1 plus 0.4, gamma is 18.5, B is 2 meter, N gamma is 3.2, RW2 is 0.5. Answer is 297.48 kilonewton per meter square while calculating. Okay. Next step, ultimate bearing capacity is given by the equation QNF equal to QU minus gamma into DF, that is ultimate bearing capacity minus overburden pressure. So now substitute value in these equations. Okay. So QE is 297.48 minus gamma is 18.5 into DF is 1.5. Answer is 269.73 kilonewton per meter square. Next step, net safe bearing capacity is calculated by net ultimate bearing capacity divided by factor of safety. So therefore net ultimate bearing capacity is 269.73 divided by factor of safety is 2.5. So answer is 107.89 kilonewton per meter square. So then set bearing capacity is given by the relation net set bearing capacity plus overburden pressure, that is gamma into df. Now substitute the value in this equation. Net set bearing capacity is 107.89 plus gamma is 18.5, depth of the footing is 1.5. So answer is 135.642 kilonewton per meter square. This is the calculation of this type of problems. Okay, but here any type of problems, slight data are changed and water table conditions are changed, you follow the same SPC calculation steps, substitute the value, finally we are getting SPC. So that is the main logic. Okay, next problems. A square footing is to be constructed on a deep deposit of sand at a depth of 0.9 meter to carry a design load of 300 kilonewton with factor of safety 2.5. Take groundwater table may rise to ground level during season. Take groundwater table may rise to groundwater level during season. Design the planned dimensions of footing given gamma saturated equal to 20.8 kilonewton per meter cube, NC equal to 25, NQ equal to 34 and N gamma equal to 32. So here Tursky's bearing capacity factor is also given. Okay, so here in these problems dimension of footing is required. Solution. Given data, size of the footing square, that is B into B. Depth of the footing is how much? Q is, load is given 300 kilonewtons. Factor of safety is given 2.5. Saturated unit weight is given 20.8 kilonewton per meter cube. NC equal to 25 is given, NQ is given 34 and N gamma is given 32. To find size of the footing equal to how much? Procedure. If water table at ground level, then draw the footing dimensions. So this is the ground level, this is the depth of the footing 0.9 meter, width of the footing B, saturated unit weight is 20.8 kilonewton per meter cube and water table starts at the ground surface. So this is the sketch as per the data. Now follow the steps. So ultimate bearing capacity for square footing is given by the following equations, that is QE equal to CNC plus gamma saturated into DF into NQ RW1 plus 0.4 times gamma saturated into B into N gamma into RW2. So from the equation RW1 is calculated by this relation 0.5 times 1 plus ZW1 by D. So here ZW1 is 0 because water table at the ground surface. So RW1 is 0.5. RW2 is 0.5 times 1 plus ZW2 by B. So here in this equation ZW2 is also 0. So B is 2 meter but answer is 0.5. Now substitute the value in the above equation. C is 0, NC is 25 plus gamma is 20.8, depth of the footing is 0.9, NQ is 34, RW1 is 0.5 plus 0.4 into gamma saturated 20.8, B as usual, N gamma 32, RW 2.5. So finally we are getting in terms of B, kilonewton per meter square. Next step. Net ultimate bearing capacity is given by the following equations, that is net ultimate bearing capacity equal to ultimate bearing capacity minus overburden pressure, that is gamma into df. So now substitute the value in this equation. So here QE is 318.24 plus 133.12 times B minus gamma is 20.8 into df is 0.9. So answer is we are getting in terms of B. 299.52 plus 133.12 times B in kilonewton per meter square. Net safe bearing capacity is given by the equation net ultimate bearing capacity divided by factor of safety. The net ultimate bearing capacity divided by factor of safety, you substitute the value in these equations. So QNE is given, divided by factor of safety is 2.5. So finally we are getting in terms of B, we are getting in kilonewton per meter square. So then safe bearing capacity is given by the equation net safe bearing capacity plus gamma saturated into df. Now substitute the value here. Okay, 1119.808 plus 53.248 B plus gamma saturated is 20.8 into df is 0.9. So finally we are getting 138.528 plus 53.248 times B in kilonewton per meter square. This is equation 1. So this is safe bearing capacity in terms of B we are getting. Okay. Next step, we calculate actual load intensity is given by the equation load equal to actual load intensity is given, that is SBC equal to load by area. So therefore use this concept and substitute the value. Here load is 300 divided by area is square footing, that is B into B. So in kilonewton per meter square. This is equation number 2. Now from equation 192, you write the equation 192. So equation 1 is 138.528 plus 53.248 is equal to 300 by B square. So while solving this equation, we are getting B is in 1.22 meters. So this is the solution of this type of problems. Let us see next problems. A square footing located at a depth of 1.3 meter below ground has to carry a safe load of 800 kilonewton. Find the wide ratio E equal to 0.55, degree of saturation SR equal to 50%, G equal to 2.67. Use Terzki's analysis for general shear failure. Assume NC equal to 37.2, NQ equal to 22.5 and N gamma equal to 19.7. Okay. Now see solution given data. Okay. Here depth of the footing is 1.3 meter, Q is 8 kilonewton, 800. Solution given data. Depth of the footing is 1.3 meter, Q is given 800 kilonewton, factor of safety is given 3, wide ratio is given 0.55, degree of saturation is given 50%, C is given 8 kilonewton per meter square, NC is given 37.2, NQ is given 22.5, N gamma is given 19.7. To find B equal to how much for square footings. So this is slightly different problems. Okay. Procedures. Draw the sketch as per the data. So this is the footings. Depth of the footing is 1.3 meter. Width of the footing is B. C is given 8 kilonewton per meter square. This is the ground levels. Okay. Next step. Bulk unit weight of soil is given by the following equations because density is not given here. So now we calculate based on the G, E, SR relations. So gamma equal to G plus E into SR by 1 plus E into gamma W. So this relation all of you remember because this relation we have already derived in GT1 in last semesters. Okay. So therefore here gamma equal to G plus E into SR by 1 plus E into gamma W. So in this equation we substitute the value. Here G is 2.67 plus E is 0.55 SR is 0.5 divided by 1 plus E is 0.55 into unit weight of water 9.81. So while solving these equations we are getting 18.64 kilonewton per meter cube. So this is equation 1. Bulk unit weight is calculated. So now follow the steps, SPC procedures. Ultimate bearing capacity for square footing for general shear failure without water table is given by the following equations. That equation is QU equal to 1.3 times CNC plus gamma DF NQ plus 0.4 times B gamma N gamma. In this equation you substitute the value. 1.3 into C is 8 into NC is 37.2 plus gamma is 18.64 into DF is 1.3 into NQ is 22.5 plus 0.4 times gamma is 18.64 into B is as usual, B is required, B into N gamma is 19.67. So while solving this equation we are getting in terms of B, that is 932.1 plus 146.88 times B in kilonewton per meter square. So next step we calculate net ultimate bearing capacity is given by the following equations, that is QNU equal to QU minus gamma into DF. So here substitute the value in this relations. So here QU is these parameters minus gamma is 18.64. So this value 18.64. Depth of the footing is 1.3. Finally we are getting value in terms of B in kilonewton per meter square. Next step, net set bearing capacity is given by the relation net ultimate bearing capacity divided by factor of safety. Now substitute the value here. QNU is these parameters 907.86 plus 146.88 times B. Whole divided by factor of safety is given 3. So now answer is 302.62 plus 48.96 times B in kilonewton per meter square. This is the solution for net set bearing capacity. So then now we calculate set bearing capacity. QS is given by the relation set bearing capacity equal to net set bearing capacity plus overburden pressure, that is gamma into DF. So therefore here net set bearing capacity is 302.62 plus 48.96 times B plus gamma is 19 into DF is 1.5. So we are getting set bearing capacity in terms of B in kilonewton per meter square, that is 326.85 plus 48.96 times B in kilonewton per meter square. This is equation number 1. Next step, the actual load intensity is given by this relation QA equal to load by area. So therefore load is given 800 divided by area is B into B in kilonewton per meter square. This is the actual load intensity in kilonewton per meter square. So this is equation number 2. Now use the from equation 1 and 2. Okay, from equation 1 and 2. So here 800 by B square into this 326.8562 plus 48.96 times B. So now you solve in terms of B. Okay, now finally we are getting the equation B cube plus 6.67 times B square equal to 16.34. So then solving this by trial and error we get B equal to 1.42 meters. So see, this is the confirmations. Here B is 1.42 cube plus 6.67 into B is 1.42 square is equal to 16.34. So now means size of the footing is 1.42 by 1.42 meters. So this is the solution of this type of problems. So these are the references are referred for session 6, okay, of module 4 with the different textbooks as well as different IS codes with different journals are referred. Thank you one and all.